feel like this at work every day.
All right. So let me see if we can get this to switch over here. Awesome. So let's kind of pick up where we left off. I think we're doing matched pairs examples. I then kind of transitioned us into thinking about ANOVA testing. So we kind of just review the general idea of this and then kind of go into some examples today. I'll show you a little bit of how we do this in Excel. Honestly, I haven't done this since I did this last year with the honors section because I don't use a lot of ANOVA, but I think I can remember how to do it. So we'll be working on that together. The basic idea behind ANOVA testing was basically we have several groups, right? So with matched pairs, it was kind of like within the same group of individuals. Now we're almost going back to where we're comparing two different groups. Just now, instead of two groups, we can have 3+, right? We can have several groups. We want to say, does the mean of this variable vary across these groups? Okay. And we can kind of talked about, if in fact they all had the same mean, it's still possible that I see different sample means, right? They could just see different samples from different parts of this distribution. But if the difference between those sample means starts to get really large, it's more likely the case that I've got different distributions, right, for each one of these groups and that they all have different means, right? So we're going to do this ANOVA testing. I kind of mentioned, like, to give you a little drawing, that we're now really just going to be looking at an F distribution, right? And so the F distribution, just to kind of recap what that looked like, there's something that had like a long right tail. So it's going to look more like this. Okay. We're going to end up calculating a F statistic, which is going to be some measure of the variation that exists across the mean of these 3 groups, 4 groups, 5 groups, however many groups we have across their means. From that statistic, right, essentially we kind of have like the assumed true difference would be we end up with like this F statistic of 0, that we see all the sample means are exactly the same. That's not probably gonna ever happen in practice, but that's kind of like what we're using as our assumption, is that all the difference between all these groups is 0. So we're coming up with some F statistic, and then our p-value is going to be kind of the area to the right of it. Now, I'm not going to give you the F table. I'll always kind of show you how the output we're going to see from Excel will give you the F statistic, but it's also always going to give you the p-value. And if we can get Excel and other programs to basically integrate that F distribution function for us, I want to move past doing a lot of this by hand and move more towards how do I use what this program is giving me, this p-value, to then start to make rejection decisions and interpret what I'm doing with this ANOVA testing. Yeah. So if you were doing this by hand, yeah, you would look. So actually, the way that the F table is constructed, if I remember correctly, most of the F tables you'll see out there, instead of giving you the area to the left, tell you the area to the right. Because we're using the F distribution, it's going to be for a variable that is always going to be. So I said the assumed true difference here is 0. It's not that the difference is 0. It's that this is kind of like the point where all these are equal to each other, and that the lowest we could ever actually see is 0. So the F distribution is censored at 0. So when we're doing something like, this is called ANOVA, so it's like analysis of variance. But we all know that the variance across all these groups has to be 0 or positive. So we're always going to come up with a test statistic that's 0 or above. So it's constructed because they know anytime you're using the F distribution, you're really only concerned with that right tail. Yeah, in practice, you wouldn't have to worry about the 1 minus anymore. But when we use Excel and things like that, it's just going to spit the p-value out of us, so we don't even have to worry about that. And we'll see. I guess I'll show you some output later today. So go down here. So what we're going to be really trying to pick up, and the way you'll see this if you look at a textbook or the way that statisticians talk about it, is you're really thinking about between groups, right? Is there variance between these different groups? Right? So I think I set it up last week, like we thought about kind of death percentages from COVID. Are there differences across these different age groups, right? Or the age groups would be our treatments, right? So is there between treatment differences? So the way you would measure this, and don't write down these formulas, I'm going to show you what they are. I am not going to make you do this by hand, okay? But what you can kind of think about this SSRT is, or some of the squares between treatments, is saying, okay, if I were to take the average of each group, so the average kind of death percentage of each age group, and then for each age group, I subtract what the overall average is. Right? So I think I have an example. Oh, I got the Anova one up there, but I think I have the grade data. Put that up there as well. Oh, let me see. I thought it might be up there on the Canvas page. I thought I put it up there. No, I did. Oh, I did the COVID stuff. Okay. So the other way I like to describe it, I think a more useful example than this COVID idea is, let's say that I had, oh, I'm not using the board. Let's say that I had three, I primarily teach three different classes, right? So I have like ECON 201, 221, and then a 330 course. Okay. So I could, across these three sections, come up with kind of the average grade, right? I could then find the average grade in 201, the average grade in my 221 course, and then the average grade in my 330 course, right? So here would be like the mean grade in these different classes I teach. And I would then compare those to my mean grade across all classes, right? So it'd be like if I had this huge data set of every single student that's been in every one of my classes, I could find the average grade. I then separate that huge data set into three groups: students who are in 201, students in 221, students in my 330 course. So I now have like three different data sets, and I find the average of each one of those. Okay? So my between treatment kind of measure is going to be taking that overall average, looking at the difference for each one of my classes between their average and the overall average, squaring that deviation, right? And then multiplying it by whatever number of students were in each one of those different types of courses, right? So it's kind of like we're getting some measure of variance here. It is basically how much does each group vary from the overall average, right? So this is going to end up being kind of my, what's going to be in my denominator of this F statistic we end up calculating. So here, once I have that, some of the squares between the treatments, I'll divide it by the number of groups I have. So here I had three courses. So C would be like 3. So C minus 1 is going to be similar to what we're doing with like a sample variance, because I'm looking at the variation across 3 different types of courses. I'll divide by 3 minus 1. Now, like I said, I'm not going to make you do this by hand, but this is what this SSRT or this MSRT is picking up. It's going to be picking up the variation that exists from these sections, or sorry, not these sections, these different courses and the overall average. Okay. So if I thought about, I have 3 different courses. For each one, I could calculate the sample mean, I could calculate the sample standard deviation, and then I have the number of students that I had from each one of these courses that I had in this sample. So that's fairly easy enough to do. So I would then go through and basically for every single, across the 3 groups, calculate like that overall average. For each group, calculate its average. I already showed you those. And then like go through and find the difference between the average and the overall average, multiply by the number of students in that section. And I could come up with some value, right? I don't want you to have to worry about kind of doing this math here, because Excel is going to do all of this behind the scenes for us. Okay? But essentially, what Excel is going to be picking up is I've got this overall average across my 3 sections or 3 courses. I then pick up how much does each course's average vary from that overall average, and then kind of dividing it by kind of the number of courses I was looking at, or to sample, so the number of courses minus 1, or the number of groups in general minus 1. So I come up with some measure of the variation that exists across these three sections or three classes or three groups. I then have to come up with a different measure, which is, okay, I might see there's certain variation across the groups, but within each group, I know that there's a certain amount of variation as well, right? Within the 221 course and within the 201 course and within the 330 course, there's just variation that exists in that data as well. And before, all I was really doing was picking up just the average of those groups, right? So I need to pick up the average, but also account for how much variation was there within each one of those groups as well. So to do that, within each, we'll look within each group, I'll take that group's variance and then weight it by however many people were in that group minus 1. I'll then divide that by the total number of observation across all groups minus the number of groups I have. This is going to be kind of our mean squared error. This is going to be the measure of variation that exists within each one of those groups. So we could use that value, those standard deviations I was showing you and the sample sizes I was showing you in the data before and come up with the mean squared error for those three courses as well. Once again, I'm not going to make you do this. I'm just kind of showing you to be complete. You could actually plug these values in and do this. So here's the most important part, right? This guy right here, okay? This is going to be our F statistic. So what our F statistic actually is the ratio of how much between treatment variation there is and how much within each group or within each treatment variation there is. So we take that mean of the squared total residuals or errors here, divided by the mean of the squared errors. Remember, this represented how much variation there was across or between treatments. This measured how much variation there was within each treatment. Okay? So I'll compare this to something that we did before. It's really similar. So I'm going to go away from this second. I'm going to come back. So remember when we were doing the correlation coefficient, kind of the sample is represented by R. So we were taking, remember, oh, I already messed this up. Hold on. We were taking, I need to make this smaller. There we go. The covariance between our X and Y variable, but we then said we need to scale it for the variance that existed within each variable. So we divided by the standard deviation of each one. That's kind of like what we're doing when we come up with that F statistic. We're taking that variation that existed between or across all treatments and then dividing it by the variation that existed within each treatment, just like we up here divided by the variation that existed within each variable. Okay? So it's kind of a similar idea. Okay? So we know this F statistic, if this is a measure of how much variation there exists across treatments, this will always be positive, or at the very lowest, 0, right? Because we can't have negative variation. The variation that exists within each group or within each course here, once again, well, it's a measure of variation. The lowest it could ever be is 0. So that's why we know our F statistic that we were talking about earlier is always going to be positive, right? And that's why we're really just looking for the area to the right of it to get our p-value. So our F statistic is basically a measure of the variation that exists across treatments while also factoring in or accounting for the variation that exists within each treatment. Now, we can do this all by hand, right? I have those slides, but this is like, I mean, if I had this on like an exam or something, like this would take the entire time. This is like not like the easiest computation. It's going to take some time. So we have Excel do it for us, and Excel will spit this F statistic back out at us. Now, if you look at an actual F table, it usually has 2 different degrees of freedoms. So I think your one is what, the number of groups you have minus 1, and the other is like the total number of observations across the groups minus the number of groups you have. You then find those 2 degrees of freedom, find your F statistic, and it'll tell you your p-value. I don't know why in the age that we have now, I bet there's no one who's using these F tables by hand. Like it just doesn't make any sense. I mean, this is the probability density function. This is terrible to integrate, right? If we're not allowing a computer to do this for us, this is going to take us forever. So, right, we're going to let a computer do this for us. Now, I kind of told you that we're always gonna, it looks more like a normal with a long right tail. If your degrees of freedoms get low enough, you end up with like kind of this like really goofy looking, almost like inverse exponential distribution. So it kind of changes shape, just like the student T changed shape when we had different degrees of freedom, right? It became more or less varied. Same thing is going to be true about the F distribution. So, you know, we could, for my example, with those 3 courses, find our F statistic, look it up on the table. We can find kind of what are our different degrees of freedom, what the actual F statistics would be that we would need to compare to at a confidence level of 0.1 or 0.05. So we can then make our rejection decision, right? It's going to be a lot easier the way I'm going to show you how to do it, which is we're just going to use a built-in tool in Excel. Okay. So if I go up here, I'm going to actually, well, actually, I had another example in here, so I'll do this one. So we could do this based off of, oh no, this is a different GPA. So we could do this based off of my course example, but I have another one that's kind of interesting. So here I've got the average attendance, and I'm sure this was for football. I can't remember. I think it was, I grabbed this from the 3 different major conferences to look at what the average attendance was for each team. Kind of, actually look at these numbers. It looks more like basketball, right? Like 17,000, 23,000 at most. So I've got every different school in each one of these conferences. Notice one of the conferences doesn't have as many observations. This is kind of nice that each group doesn't have to have the same sample size. Okay. So if I go up here to where I've got this data tab, one thing I might have to add in, I want to use this data analysis that's over here. Now, if you open your Excel, you may not have this. And I think on a Mac, sometimes this can be a pain if you have an older Mac to add in. However, we're starting to get far enough removed from that to where you probably can do it in a similar way, or at least it will look very similar to what I'm about to show you on a PC. Okay. So you'll go to File, and then go down here to Options. I think on some of the different versions of Mac, you have to go to Tools and down to Options. But once you get to Options, there should be this thing called Add-ins. Like I said, I think on some Macs, this might be under Tools. So if you're not, you guys seen this on your Macs or no? It is under Tools? Okay, yeah. So if you go to Tools, you should see this Add-ins. Okay. Is everybody able to find that okay or no? Yeah. It should be like on the very top toolbar that you have, or toolbar. Tools is under toolbar, but it's that top like toolbar that you should have. Yeah, outside of it, like yeah. Mine like, doesn't look anything like, right. PCs look very different than Macs in that regard. So we're able to find it. Okay. So once you have that add-ins, you should have, and yours looks very different on a Mac. I think it's like in the middle of the box maybe, but there should be something that says like manage. Is anyone seeing that on your Macs? Do you see the manage option? No? You see it? Okay. Like I said, it's not down at the bottom, but I think it's somewhere like up towards the middle of that, whatever box pulls open once you click on add-ons. Did you guys find it or no? So, and then you hit go, there should be this analysis tool pack is really the one that you want. Yeah. Did you guys skip a step on the Mac? Is there like, you don't have to hit the go, right? Yeah, it's just right there. Yep. Okay, sorry, yeah. So once again, if you don't have them, none of you have a non-Mac, do you? Okay, one. We got one person who's doing the right thing. No, I'm just joking. But so if you go to, you're looking at that add-ins, you won't have to hit the go on manage on a Mac. It should just be there as an option that you can add in this analysis tool pack. Okay. Anyone still having problems? It's okay if you are.
I wasn't able to like open it up until you got way into
Yeah.
it.
Okay.
I don't have a Mac, so
My computer's just very slow.
Okay.
Yeah.
All right. So if you don't have a Mac, if you've got Excel open, right?
Yeah.
Go to File. Go all the way to the bottom, you should see Options, right? So once you go to Options, you go down here, there's an add-ins tab on the left-hand side as well. Okay, that's so far. Then it should say manage down here. Now, I don't know why these other ones would be selected. It should default to the Excel add-ins, but if it's not, you'd have to go to manage Excel add-ins. Okay. Then once you hit go, you've got these 4 options. You just want to make sure that the analysis tool pack is selected. Yeah.
I don't know why, like when I go to I have a Mac, so I click tools, and then I go down to I see Excel add-ins, but it's not like it's like grayed out.
Do you have Excel open?
Yeah.
Why would that be grayed out? Are you connected to the internet right now?
Yeah.
Why is it grayed out? I might have to help you after class. I'm trying to think where that gets grayed out. I know there's a reason. I'm not a Mac expert. I'll be the first to admit I'm very much a novice, but I know I had someone that had that issue last year, and I forget what it was like a really stupid thing that why it's grayed out. And I thought it had something to do with either maybe Excel needed to be open or not open when you were looking at, or did you have Excel open when you guys were looking at tools? So you have to have Excel open, and I thought sometimes with the add-in, you had to make sure you're connected to the internet. And then there was one other thing that we had to make sure it was graying it out because it's been a long time now.
Does it apply it to this like workbook or sheet? Or
It should, after you get it added in, it should always show up there. So like on a PC too, like once you do it once, it should always be on there. Unless you like wipe your computer, like they do the ones that you use. So if you're using a university computer, you literally have to do this. Like if I was using this, I'd have to do it every single time we got to class because they wipe the computers every night or whatever. So, but yeah, we'll try to figure it out afterwards. I can't remember why, but I've had that happen to someone in the past too, and it was a really dumb fix. But for the sake of like, once we make sure we'll all get it on there, this is kind of what we'll do. So we'll have this data analysis tab that should be, or sorry, data analysis tool that should be under the data tab here. So I'm going to do single factor ANOVA. So this is where we've started out. We just want to know, is there differences across the grades in the courses I teach? Or in this case, are there differences in the average attendance across these 3 major conferences? I guess I think this might have been basketball now that I'm looking at the actual numbers. So I go to this single factor ANOVA. I hit OK. So this input range, I'm going to select the entire data, right? So I'll select this entire data here. Okay. I'll then go hit that little arrow back, so it'll show me this. So I selected the data and hit my little arrow. The grouping is by columns here. If I had it by rows, that would be fine as well. But usually data we have grouped in columns, right? So I also have to make sure as we start using this data analysis tab, it needs to identify if I've used labels. So I selected the labels when I was selecting this, because if I don't, the output's going to look a little wonky. I'll show you what it looks like if I don't select the labels. But because I selected them, I have to let Excel know that I did. So I got to make sure there's a check mark there. I'll leave it at the 95% confidence level for right now, or leave alpha at 0.05. And then I usually put things on a new worksheet. Just because it makes it a little bit easier for me, especially as we're walking through these in class. So now if I hit OK, I'll kind of see my output here. Okay. So it gives me a couple things. Right? First of all, it kind of shows me that behind the scenes, what it did was it calculated the sample size from each group. It calculated the sample mean from each group, and it also found the sample variance. So these were the things that we needed to then compute between group variation and within group variation. So this was like my MSTR, and this is my MSE, mean of the squares, total residuals, and my mean of the squared errors. So what it then does for me, see if I can prove this to you here. I'll blow this up a little bit. So what it should be doing here to get this F statistic is it takes the between group total measure of variation, dividing it by the within group measure of variation. And that's how it's coming up with that F statistic. Okay? But it's doing all that for you. Does that not spit out at you the
Mine did,
results?
his did.
So let's make sure I have an idea what could happen. Do not select this title, right? You just want to select the first kind of row of labels. So when we're looking at that data tab, and we did single factor ANOVA, made sure that was selected. When I selected the data, I wanted to start where this first row of labels. Now you got it? Yep. You have to make sure that you tell it the labels were, if you didn't tell it the labels were accepted, you're going to start getting errors, right? Yeah, so you do have to make sure you do the single factor as opposed to the two factor. Yep, that's the next thing we're going to talk about. Yeah, so single factor. Is everybody else, anyone else having problems with this? Okay with this so far? Okay. So we'll hit cancel here. So where was that? I had it on sheet 2. So I noticed what I told you is it's taking the ratio of between group to the within group variation, and it's just doing it behind the scenes. It's just giving you all the intermediate steps here. It then is looking that F statistic up and giving you your p-value. Okay. Now, here we've got a really high p-value. What this is telling me is that based off of this data, I can't say that there's any variation in average attendance across these three groups, right? That when I come up with the p-value, the only way that I could reject the null is if that p-value is less than my alpha of 0.05 or 0.01. So remember what we always start out with this ANOVA testing is that, well, what were my 3 conferences? I think I had like the Big Ten, the SEC, and I forget the other one. Was it Big 12? Okay. So I'm assuming they're all equal to each other. Based off the sample evidence I found, I can't reject this. I can't say that I found any significant evidence that there's variation in the average attendance across these 3 conferences. If I had the actual data, I could do, oh no, I don't think I brought it with me, which is kind of unfortunate. Maybe I'll bring it next class, but if I had the data with each one of my courses and the different kind of students, I would basically do it the same way. I would just select the 3 columns, run the regression, and see if I could find if there's any significant difference in the average grade across those 3 courses. Oh, what's something else I could do here? So I don't necessarily need to dive into 2A ANOVA quite yet. I did show you the old grade data. Is this? Maybe this was it. I think this is all one section, so I can't do much there. I think the original one I had somewhere else because I had names with it. Let me think about how I could use this real quick. Let me do. Okay, I can do it with this data set. I'll just kind of show you some other output because I think it's kind of interesting. So here I had different GPAs and where people sat. What is GPA row? Oh, okay, just copy and paste them. And where people sat in the class, right? So they sit in the front row, the middle row, or the back row. So one of the issues with looking at ANOVA testing, when we start adding in 2 factors, is anytime I have labels, I want to try to convert those into numbers. So notice here I did front row, middle row, back row. I change those to 1s, 2s, and 3s. So let's say instead I had this data, let's say it came in like this. in order to do that single factor ANOVA, I need to either have my groups all in the same row or all in the same column. So here, maybe I want to see, is there differences in the GPA that someone earns depending on what row they sit in? Okay. Well, here I've got front row individuals, middle and back row. Well, I need to sort these. So one real nice way to do this would be if I use Control Shift or Command Shift on a Mac, hit the down arrow, and then filter my data. So let me go, I'm going to sort it here. What I basically need to do is copy and paste my GPA so that I have everybody that sat in the back. So I'm going to copy this over here. And this was back row. I'm then going to take everybody that sat in the front row, copy them over here. And then everyone that sat in the middle row should be everyone here. Okay. So let's say I had these GPAs and I had where the person sat. I could basically, so I'll go to data analysis, single factor ANOVA. I'll select these three, right? These three columns. I selected my labels, right? That was part of my selection. The data is organized in columns. So when I hit OK here, I should get this output that eventually gives me this p-value to say, can I reject, right? What would I be assuming here? Here I'd be assuming that the mean GPA in the front row, middle row, and back row are all the same. So if I can get a p-value that's low enough, that it's less than like an alpha of 0.05, then I could start to say I can reject that sitting in the same or sitting in different rows has no influence on my GPA, right? Because if I can reject this, really what I'm saying is I'm rejecting that the GPA is the same across these different kind of locations in the classroom. So I hit OK. You can look here. My p-value is pretty much 0, right? E to the negative 0.06. So if I've got a p-value that's approximately 0, I can reject that null, or said differently, right? I'm rejecting that the GPA was the same across the front, middle, and back row, or that there was significant variation across the seat location of the student. Now, I'm not necessarily saying, I think I grabbed this data from something that was using this data to make a point. These aren't actual GPAs, but right, it's another example of kind of shows the application of this ANOVA testing, right? You start to test for differences in whatever variable you're interested in this case, GPA, and here it was across the location of where someone sat in the class. Any questions on any of that? I know I worked through that last one kind of quick. I just wanted to show you another example. Sometimes you have to move the data around a little bit to do this ANOVA factor or ANOVA testing in Excel because it needs it to be organized in different columns or in different rows. Would have taken a lot more time to move everything around in rows there. That's why I did it by columns. We're okay with this? So, this saves us a lot of time. We don't have to do all this work by hand. To me, this makes a lot more sense because it really allows us to get at the question, question that we have in mind a lot quicker. So, and then this was one of my favorite memes also, ANOVA one, because that was one factor ANOVA. All right, so I want to try to get this up for next class. I didn't have time to get all the data in there, but I think it'll be interesting to work in some vaccination percentages. So I'll repost that COVID data before class Wednesday, and we'll take a look at some one factor ANOVA stuff. So we had matched pairs, which we started to look within individuals. This one factor ANOVA starts to allow us to think about, well, are there differences in the mean because of this one factor, right? Because the team's in a different conference, because it's the student's in a different course, or because the student's sitting in a different row in the class, right? So I can start to analyze how this variable I'm interested in changes because of this one factor. But I know that in most situations, more than one factor is going to matter. So I can start to do two-way ANOVA testing as well. Right? This is going to be where I now have two factors that I think influence the mean of this variable that I'm interested in. Okay, so I think in the one that I was copying and pasting, instead of just where the person sits in the class, I would also look at, well, maybe there's some role that gender plays in GPA as well. And maybe there's some way in which gender and seat location are related that are also correlated with GPA. So maybe there's something about personality differences or something. And so maybe that, you know, if males are more likely to choose the back of the class or they're the front of the class, and being in the front versus the back has a different output on what you're learning, right? Maybe there's some type of interaction there, right? So not that I don't necessarily know if any of that's true. That was just the example I have, right? That could be something that someone hypothesizes, right? And then maybe you can use the data to show like, no, that's absurd, right? It doesn't play a role at all, okay? So with two-way ANOVA, we're gonna be doing a similar thing, okay? But instead, right, when we think about a cross treatment variation, we're gonna have variation that exists across two factors. So one way we're gonna look for the variation that in the variable across our first factor, then the variation that exists across the second factor, look at the ratio of those relative to the variation that exists within each group. Excuse me, so I can now come up with two F statistics and two corresponding p-values, right? So I can now start to say, is there variation in this variable, maybe it's GPA, with respect to gender, but also with respect to seat location? And the interpretation then becomes also, not just is there variation with those two factors, is there variation across gender holding constant the row location choice? And is there variation across row location choice holding constant gender of the individual, right? So I can now start to control for one of the factors, and then, you know, that gives me a little bit more power. Okay? So one issue with how we're going to do this in Excel is, and I won't make you guys do this by hand, but the problem is we're going to have to kind of come up with the averages and tell Excel the averages and the sample sizes. You can't just select the data and have it be able to do it on its own. Or at least it's a lot easier if we kind of have this data summarized. So we go down here, right? Really what we're testing for now is the first F statistic tells us if I hold constant the column, so this 1 would mean I hold constant whatever the other variable is there variation across the different rows? And then the other F statistic will be against the null and alternative hypothesis of if I hold constant the row, is there variation across the columns in the average of whatever variable we're looking at? I wouldn't get too lost in these. I'm never going to make you write out the null and alternative hypothesis for ANOVA testing. But what you're really thinking about is you have two F statistics. One is going to tell you whether or not there's variation across your rows. One of them is going to tell you whether or not there's variation across your columns. Okay. So we go forward here. Well, maybe I think about something like income. So I went out and grabbed, just to kind of, I think showing the data makes it easier to set these topics up. So you can get, I think we looked at this way back when we did group averages, but you can get income data from the government, but which that comes from the IRS, but it's only grouped. You can't like view every single observation. So here you can get the average income by race and level of education, right? Now, obviously race is kind of boiled down into somewhat three simplistic categories here. You know, we could expound upon these, but in terms of how the government collects it, they kind of have it collected at these kind of different levels. When I was grabbing it from the website, they actually had kind of grouped in kind of white and Asian individuals in the same category. Like I said, you would think you would want to be able to break this down by more, but this is just how the data came in. This is just how it was grouped, right? So, oops, sorry. So what you would actually want to do in practice, right, is I'm thinking about, if I look at within each race, notice what's happening to incomes as I look at higher levels of education, right? It's increasing within each race. Right? However, if I look at holding constant in education level, I notice that there's very different averages incomes across the races. So even if I'm holding constant the level of education, it looks like, at least based off my sample evidence, there is some variation across race as well. Right? Now, how can I say if it's enough variation that based off the sample evidence that there's differences across these groups holding constant this other factor, which is the education level? And how can I say that maybe there's differences in the average income across education levels holding constant kind of the race of the individual? Right? So I can do this with two-way factor Anova testing, right? So what you're going to kind of do, you'll have these different factor means. You don't have to calculate these in practice, but Excel is kind of what it's doing behind the scenes is calculating like what the average income is for each race. So that would be like your factor A mean. And then it's going to calculate the average mean within each type of education level. It's then going to use those to pick up variation of, say, it's the Hispanic average income at the high school level, Black average income at the high school level, white, Asian income at the high school level. So it's going to be starting to pick up variation from each one of these different combinations of kind of race and education from what the average income is at each one of those education levels and what the average income is across each of these different racial categories. Okay. It's then going to look at that variation with respect to the within treatment variation and give you kind of two F statistics here. Okay. So it'll tell you this is what the Excel output looks like. And next class, I'll give you some data sets and we'll see how we run this in Excel. But for now, I just want to show you what the Excel output looks like and how we interpret it. Okay. So these were our two factors. Our rows were education and our columns were the different race categories. Okay. So when I look at this output, the variation that existed because of the rows was education. So it's like saying, holding constant the race of the individual, what was the variation that existed because of education level? Right? And it looks like they had a really high F statistic, which means it has a really low p-value. Okay. So this low p-value means that at any level, we can reject the null hypothesis. So when we're thinking about what hypothesis are we rejecting, when we're looking at the p-value associated with the rows, the null hypothesis there is that across the rows, income levels were the same. Or across the rows, that income was the same across all education levels. So it kind of makes sense that we can reject that, right? We're saying that there's definitely, we found a lot of evidence that income actually varies a lot with education level, right? Or varies a lot across the rows, okay? So we can reject there's no variation in average income across different education levels with 99.999% certainty, right? So that makes a lot of sense, right? And that was holding constant kind of the race of the individual. Now, if I think about the variation that exists in the columns, so holding constant the education level of the individual, the variation that existed across the kind of racial categories, we can reject at the what? 90 and 95% level, or the 10 and 5% significance level. So we can reject that there was no variation in the average income across these races, right? Which is a bad thing, right? In the sense that like that shows that there's some racial inequality in terms of income, right? So because even when we held constant the education level, even if there was different education levels across these different racial categories, we controlled for that. So we're saying even controlling for the amount of education the person had, we see that there's variation across these different racial categories in average income. So this is bad, right? This is not a good hypothesis to be able to reject here. I guess one bright, one silver lining is we can't quite say that there's differences in the income level at the 99% level, right? Our p-value is slightly above 0.01. So even though it's pretty strong evidence that there's variation across race, even holding constant the education level, fingers crossed, maybe, right? We just have some bad samples, but I mean, 95% certainty is still pretty high. This isn't very good, right? So if we're thinking about what we can say here, when it comes to the education level, right? Holding the columns constant, holding the race of the individual constant, we find that there's definitely variation in income across the different levels of education. However, for the variation that exists because of the columns or existed because of the different racial categories, holding constant the education, we do still see that there's some evidence that the income varies across the racial categories, although we would fail to reject at that highest level, right? We couldn't quite say with 99% certainty that there's any variation in the average income holding constant education across these three different kind of racial categories. Right? So you can kind of see we start to get some power with this two-way factor Anova, because now it's not just is there variation, but is there variation holding constant? One of these other things that we know is important, right? We know the education level is important. right? And if that varies across race, then we may be picking up, if we do single factor ANOVA and we just use racial category, we may be picking up some of that. But with two-way factor ANOVA, it's even more powerful. We can now control for this thing, which is education level, that we think might vary across the different racial categories. And so now we can speak more specifically to, even if we saw the same level of education, do we now see that there's also still variation across racial categories, which would be more powerful in speaking to like actual discrimination, right? Or like even if you want to do this like gender discrimination, if you want to control for the level of education as well, right? That's a little bit more powerful. Like you wouldn't find the 70 cents to the dollar, but you might, you would now be accounting for education levels. And there probably still is a difference, just looking at knowing somewhat what the data looks like, but it probably wouldn't be as strong, right? So we're kind of working our way up to the next topic, which will start Wednesday. I'll show you a little bit of how to do this two-way factor stuff in Excel, but then we'll start talking about linear regression, which allows for us not to only control for one thing, but we can actually control for X number of things, as many things as we want. And pick up some differences in like the relationship between two different variables, not just identify differences in means, okay? All right, I know this is a lot. Like I said, we'll take another look at it in Excel on Wednesday. And then from here on out, we're basically just dealing with regression, which is my favorite category, okay? So I will see you guys on Wednesday. I also may put up